So now when we have a system of blocks, when we have a question in which you have more than one block connected to string or even pushing each other, like you're moving two boxes, there in the book is some examples. The way of resolving this question is the same. It's the same steps. The only difference, you have two objects. Okay? So let's read the question, let's write some data, and then let's follow the same approach we did yesterday. They say two blocks A and B are lying on a table and are connected by a piece of string. The mass of a box A is 3 kilograms. Let's maybe write the data here. Let's write mass A is equal to 3 kilograms. And the mass of box B is 2 kilograms. So mass B is 2 kilograms. Assume that the mass of the string is very small, so we can ignore the string. So the string doesn't have a mass. It's there, but doesn't have a mass. Okay? A 30 Newton force is pointing to the right. That is the force, applied force. And note the following. This applied force is only acting on B. So that applied force is not acting on A. A is moving because there is a row between A and B. Are you with me? Okay. Where I stopped, pulling is pointed to the right, is applied on box B, causing the two boxes to move. Obviously, both of them move because they are connected, but the force was applied on B. The surface acts with a frictional force of 5,9 for A, so the frictional force here for A is equal to 5,9 Newton and 4,1 for B. So the frictional force for B is equal to 4,1 Newton. There we go. That is the data we have. Now they say calculate the acceleration of box A and B. It's the same acceleration because they are moving together. They are moving at the same time. So the acceleration will be the same. Okay? So now, remember what we did yesterday first when we solved this question. What was the first thing we did after writing the data? What we did? So let's draw the free body diagram. So let's write here for A, for instance, and let's write here for B. Okay? And let's draw the two free body diagrams there. Now, for this free body diagram, you can edit the axis or not. It doesn't matter. It's not part of the question. Remember I told you, if it's part of the question, you cannot include the axis because you can lose marks. All right? So for A, what forces are acting on box A? If we come here, we have that rope is pulling that block to the front. Can you see that there? Are you looking there? So that is T, that is tension. That is the tension that is in the rope. So if we come here, we represent that tension there. And I'm going to call this one tension B on A. No, not F, I want to use tension, simple tension. No, you can write just tension, you know. You can just write the capital T and maybe it will be even better for you. What other forces are acting there on that box A? There is weight, which is straight down. Weight. There is normal, pointing straight, perpendicular to the surface, in this case straight up. And there is friction in the opposite direction of motion. This one is frictional force. Those are the forces acting on that box A. If this one was for mark, then you'll get 4 marks, 1 mark per force. So let's go to block B, and then what forces are acting on block B? Not the same as block A. First of all, we have an applied force to the right. You can see there is 30 Newton. There is a 30 Newton. There is also weight. There is also weight. There is also normal. What else is there? There is tension, which is the same rope, therefore it's the same tension, but it's in the opposite direction. Can you see that on that? So it's tension pointing backward in the opposite direction towards A. That is tension. And there is also friction, also in the opposite direction. I'm going to write it right on top of the other one. That one is friction. It doesn't really matter where you draw it as long as they are on the same line. I know some people like to put one below, the other one on top. It doesn't really matter. As long as they are straight and not too far from each other. Okay? Because all the forces must come from the point. So that is step number 1. You draw the free body diagram for both blocks, separated as I did there. Okay? So now, what are we going to do? We're looking for acceleration. We are going to apply Newton's law on each of them, separated. So we're going to start with Newton's second law for A. So we come for A and we say F net is equal to ma. I'm applying Newton's second law because the object is accelerating. They're asking to calculate the acceleration. And because the object is moving in the x-axis, I'm working in x-axis. And I also said you don't have to write that one. It's fine. So what forces are there? There is tension. We're going to take this direction as positive. That direction is positive for both blocks because the block is moving in that direction. So I have tension minus frictional force is equal to mass multiplied by acceleration. All right? Let's substitute what we have. All right? Tension is not given to us with no tension, so we write the letter. Frictional force was how much? Yes, 5.9 Newton. No, I'm not going to write the Newton either. Is equal to mass was 3 kilograms. 3 multiplied by 8. Can we carry on here? We cannot. Why can we not go on? Because we have two unknown. We don't know tension and we don't know acceleration. So we stop there. Because we cannot go on. And we are going to call this whole thing here, I am going to call it equation 1. And I'm going to stop there because I have two unknown. Is that understood? So you stop there and then you go to do exactly the same for block B. Alright, so you come for block B, which is here. F net is equal to MA, also in X, in X-axis. What forces I have here in the X-axis? And we're going to keep that direction as positive. In Newton's law, it's recommended to keep or to use the direction in which the object is moving as positive. Right. So in this case, we have now applied force minus tension minus frictional force is equal to MA. Is that fine? Are you with me here? Okay. So now here, the applied force is given to us and it was equal to 30. The tension, we don't know the tension. Frictional force is given to us is 4.1 for this one. I keep confusing those two friction. 4.1. 4.1 is equal to 2A, 2A. Can we go on? Yes, we can go one more step. We can add 30 and negative 4.1. How much is 30 minus 4.1? Excuse me? 25.9. So it's 25.9 minus t is equal to 2a. Can we go on? No, we cannot anymore because once more we have two unknown. And we're going to stop there and we're going to call this one equation 2. And now we are going to use the mathematics that you all know. We are going to work with those two equations simultaneously. How do you solve this one in mathematics? There are different ways. You can substitute for one of them in the other equation. You can do different way of solving this one. I personally like to add the equation. I think it's easier, but guys, be my guest. You use whatever method with your teacher you think is easier for you, okay? So what I generally do, I say adding 1 plus 2. Learn to work organized because it will help you to understand also when you study. So now I'm going to add When you add, what you do? You add everything from the left hand side with everything from the left hand side and everything to the right with everything to the right. So in other words, I am going to add, and let me maybe use a color so you can see what I'm saying. I'm going to add this side here with this side here. That is left hand side. So I'm adding both of them, like adding, like a plus. So I'm going to write, for the first one I have t minus 5,9. I'm going to add that of the other equation. Plus 25,9 minus t. That was everything from the left hand side. And now I'm going to do the same with the right hand side. I'm going to add everything that is on the right hand side. In other words, this one and this one. I'm adding the two of them. So it's 3a plus 2a. So now what happened here? We go to common factors, isn't it? Simple math. This t cancel with that t. T's are gone because it's the same t, the same row. Okay? And then you add these two numbers and these two numbers because they are common factors there. So saying that, we have 25,9 minus 5,9. How much is that? Yes, 20, nothing. This is equal to 5a. Are you with me here? Then a is equal to 20 divided by 5. Please your calculator. It is 4. That is not a 4. 4 meters per second square. It's a positive, it's in that direction. Same direction of motion. That is our acceleration done. This part of the simultaneous equation is more like, it's intimidating perhaps, but not really difficult. Not really difficult, okay? And then now the next part of the question, they ask you to, let me just go there. They ask you to calculate the tension. You go here. They say calculate the magnitude of the tension. Okay? And guys, the magnitude of the tension is now once more mathematics. You substitute A in either one of the two equations. You see? You substitute A in either one of the two equations. Let's use one. To me, ones look easier because T is positive. But really, it does not matter. You can substitute in any of them. So let's come to this side here. I'm going to rewrite the equation clean. T minus 5,9 is equal to 3a. Are you there? Sorry. There we go. You see? It's the same equation. I didn't change anything at all. I just rewrite it clean. How much is a? It's 4. So I am going to substitute 4 in that equation. So I have t minus 5,9, this is a 9, is equal to 3a, but a is 4. Now please, your calculators, guys. T is equal to 3 times 4. Are you sure? 12 plus 5,9, and then T is equal to 9 Newton. We are done. Any question there?